Hello everyone, I am Prem Kumar. Welcome to Olympiad's Math Academy. So today I am going to discuss with you a very interesting topic. The greatest integer function and fractional part functions. This is very essential for IOQM. At least one question they will ask. Okay, next video will be modulus. One shot I will post for you. Okay, so today I am going to focus on the fractional part function and greatest integer functions. We'll discuss what is the fractional part functions, what is the greatest integer functions, what is the relationship between them, how to draw the graph, what is the properties of that, how to solve the problems. We'll discuss, right, one by one. So first we can discuss the greatest integer functions. The greatest integer function is a function. So greatest integer function is a function from real number to integers. Okay. So input can be any real number, but output should be always integer, right? So the definition of this will be greatest integer function always less than or equal to x. For example, if I take this is like a mission, the greatest integer function is like a mission, right? Let's take a 2.5. You can take the greatest integer function of 2.5. You will get output. So we need the greatest integer less than or equal to 2.5. So 2.5 is not an integer. You can see here the number line. You can see. You can take this is 2, this is 3, this is 2.5. So you can take less than or equal to 2.5. 2.5 is not an integer. Which is the greatest integer less than or equal to 2.5? That is 2, right? Therefore, the greatest integer function of 2.5 will be 2. Okay. Let's take a minus 2.5. You can take. What is the greatest integer function of minus 2.5? You can see that will be, minus 3, right? Why? Because you can see here, this is minus 2, this is minus 3, here is minus 2.5 is there. So minus 2.5. So we need actually greatest integer function minus 2.5 less than or equal to minus 2.5. So minus 2.5 is not an integer. Therefore, which is the greatest integer less than or equal to minus 2.5? That is minus 3, right? This is your greatest integer. So I hope everyone understood, right? For example, if I take pi value, greatest integer function of pi is 3.14. The greatest integer function of 3.14 is what? 3. Understood? What is the greatest integer function of minus? So minus 4, because minus 3.14 it will be minus 4. I hope everyone understood, right? Okay. Let's take one more example. Let's take 1 by 3. What is the greatest integer function? 1 by 3 is what? 0.3333 goes, right? So it will be 0. So then how to define the greatest integer function? You can see the greatest integer function is defined like this. Suppose if I take x is 0 to 1, you can take 0 to 1 in this closed interval. 0 included, 1 is not included. If you take that any real number, you will get what? 0, right? Because 0.5 you can take, greatest integer will be 0. If I take 0.999, you can take 0 only. So you should not include 1. So it will be 0. Let's take, if I take 1 included, less than 2 is 1, right? Because 1 to 2, so 1.5 you take greatest integer function, because greatest integer function is less than or equal to 1.5. 1.5 is not an integer. Which is the greatest integer less than or equal to 1.5? It is 1 only, right? So next you can see, if I take 2 included less than 3, that is 2. The same way, if we included 3 less than 4, that is 3. Clear? So if you included a minus 1, suppose if I included minus 1 less than x less than 0, this interval is what? So for example, minus 0.5, the greatest integer is what? Minus 1. I hope everyone understood, right? Then how to draw the graph of this? You can see here, students, very simple. Draw x-axis and y-axis, and 0 to 1, you can mark it the number line 1, 2, 3, here minus 1, minus 2, minus 3 here. Here you can put 1, 2, 3, here minus 1, minus 2, minus 3. I hope everyone understood, right? Okay. So now you can see the 0 to 1 you can take, this is 0 comma 0, right? 0 to 1 you can take. So what will get? 0. So that means this is will be y, right? The greatest, x is the input, greatest integer you can apply, the output will be y, right? The y is lies along the y axis, right? Okay. 0 to 1 you can take, the greatest integer value is 0, 0 to 1. So y is equal to 0 is included, here is 1 is not included. When you take 1, it will be 1. So that means if you take any integer's value, the greatest integer will be integers only, the same integers only, right? So when you take greatest integer of 1, 1, greatest integer of 10, 10 only, okay? So when you take 1 to 2, it will be y is equal to 1, right? It will be y is equal to, this is y is equal to 0, this is y is equal to 1, right? Let's take 2 to 3, so it will be jump over here 2, so 2 to 3 is 2, clear? Okay. Let's take minus 1 to 0, minus 1 if you include it, so minus 1 included here, y is equal to minus 1, right? Let's take here, it's 0 is not included. The step functions, you can see the same way you can, so take, right? This is your step functions. This is y is equal to minus 1, y is equal to minus 2. If you take minus 2 to minus 1, so for example, minus 1.5 you take, the greatest integer function of minus 1.5 will be minus 2. So I hope everyone understood. This is your step functions, right? Or floor functions you can say, right? Okay. Then how to understand this properties? We'll discuss the properties first, right? So the first property you can see the greatest integer function, you can see here, the greatest integer function by definition is would always less than or equal to x, but it should be more than x minus 1. It should be more than 1, the first thing, right? Okay. And second thing you can see, if you not able to understand, let's take 1.5. So 1.5 greatest integer is what? 1. 1 is less than or equal to 1.5, and it should be, you can see 1.5 minus 1 is what? 0.5. 0.5 is less than, you can see 1 less than 1.5. It satisfies the inequality, right? Okay. Let me state next property. The greatest integer function of x plus or minus n is equal to greatest integer function of x plus or minus n, and n belongs to integer. What is the meaning actually? So when you take, for example, if I take x plus 1, the greatest integer, you can split it. You can insert the greatest integer functions, right? Like this. When here 1 is belongs to integer, that's why you can splitting. But it will not true for other than the integers. For example, 1.5, you can take x plus 1.5 greatest integer function. It will not equal to greatest integer function plus 1.5. That's not true. This is only for integers, right? Okay. So if you take x minus 2, so we can write greatest integer function minus 2 you can write. Clear? So if I take, let's take x plus 9 you can take, the greatest integer function plus 9 you can write. Understood? Because these are integers. I hope everyone understood. Let's take third one. Third one, you can see the greatest integer function of x plus y is always greater than or equal to greatest integer function plus greatest integer function of y. Okay. So you can verify through any real number. So this is true for all x, y belongs to real number, right? You can verify through some example, right? Okay. Let's take the fourth one. Suppose the greatest integer function are greater than or equal to n. N here is belongs to integer. N is belongs to integer. then where the x values lies, we need to find out. For example, if I take greatest integer function is greater than or equal to, let's take 2. First, these kind of questions, what you can do, 2 is there, now you can fix it on the number line, right? You can take less than 2 or more than 2, you can take any value. Suppose if I take less than 2, what will get? Let's take 1.5. 1.5 greatest integer value is what? 1, right? So 1 is greater than 2, it's not possible. So you can take, so 2 if you put here, 2 is greater than or equal to 2 is satisfied. So if I take strictly less than 2, there is no x value satisfied. So therefore what we can say here, let's take 2 to 3. So if I take 2.999, you can take. So the 2 only, greatest integer value is what? 2, it's greater than 2. Let's take, 3 if you take. 3 is greater than 2, right? So it's satisfied. So from this, what we can say here, x is greater than or equal to 2, we can say, right? The inequality is satisfied means the x should be equal to 2 or more than 2. Then only satisfied. If you take less than 2, this will not be satisfied. Okay. So therefore here how to write? If greatest integer function is greater than or equal to n means x should be greater than or equal to n, you can write. Understood? Suppose next fifth one, suppose greatest integer function strictly greater than n, not equal to, right? In that case, here n belongs to integer. Let me take greatest integer function strictly greater than 2. First, you can draw the number line. You can fill the 2 here. It's less than 2 you can take. It's not possible here. But you can take 2 point, let's take here 2.5 you can take. 2.5 greatest integer function is what? 2. 2 is greater than 2. It's not possible, right? So you can take 3 or more than 3 is possible, right? So definitely less than 2 is not possible. If I take less than 2, let's take 1.5. 1.5 greatest integer function is what? 1. So 1 is greater than 2 is not possible. You cannot, you can take 2 to 3 is possible or not? You can take, but what will happen if a 2.999 greatest integer will be 2 only. So 2 is greater than 2 is not possible. Therefore, you can start from 3. Okay, so this implies x is greater than or equal to 3. Understood? 3 greater than 2, no? Right. Understood? Okay, so then how to rewrite this? This should be, x should be greater than, so you can take, so 3 if you take, 3 is more than 2 only, no? Yes, correct. 3 we can take, right? So how to write this one quickly? Okay, so x is greater than n plus 1 we can take. So n, suppose here n is 2, 2 plus 1 is 3, or greater than or equal to n is possible, right? So n you replace here 2, 2 plus 1 is 3, x is greater than or equal to 3. Clear? N belongs to integers, right? Let's take another one. So greatest integer function strictly less than or equal to n. Okay, that case, what are the x value possible? Here n belongs to integer. Suppose let's take a greatest integer function less than or equal to 2 you can take. Okay, less than or equal to 2 means you can fix the 2 here. Let's take less than 2, you can check it. Let's take 1.5. 1.5 greatest integer function is what? 1. 1 is less than or equal to 2 is possible or not? It's possible. Let's take more than 2. Let's take 3. 2 to 3 you can take. 2.5 greatest integer function, it is 2. 2 less than 2 is possible. If I take 3, 3 less than 2 are not possible. So you can take strictly less than 3. Understood? So then you can see x should be less than 3 you can take. You cannot take 3. Strictly less than 3. Because you can take in between 2 and 3 also. Because 2.9999 greatest integer is what? 2. 2 is less than or equal to 2, right? Okay. Fine. So therefore, then how to write this one? So x should be strictly less than n plus 1. Clear? Here n is what? 2. 2 plus 1 is 3. X should be less than 3. It's possible, right? Let's take next one. Greatest integer function is strictly less than n. That case you can take. Here n is belongs to integer. Okay. So let us take greatest integer function strictly less than 2 you can take. So let's draw the number line. Let's take 2 here. Less than 2 is take, for example, 1.5. So definitely 1 is less than 2, right? It's possible. But if you take 2 to 3, you can take 2.5. 2.5 is what? Greatest integer will be 2. 2 less than 2, not possible. So you cannot take more than 2, right? So that means x should be strictly less than 2 only possible. Because 1.5 is greatest integer will be 1. 1 less than 2. You cannot take 2 also. More than 2 you cannot take. If I take more than 2, let's take 2.5. The greatest integer is 2 only. If I take 3, 3 greatest integer value of 3 is what? 3. 3 less than 2. It's not possible. Therefore, you have to take x should be strictly less than 2. That means here is x should be less than n. Then only it's satisfied. Okay. So you cannot include 2 also. I hope everyone understood, right? Okay, let's go to the next thing. Okay, let's do the next is 8th one. You can say 8th one only, no? 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the greatest integer function of the greatest integer. The greatest integer always integer. If you take one more greatest integer, again it will be greatest integer only. So integer value only will get. Okay. Next, you can see the greatest integer function of x plus greatest integer function of x plus 1 by n plus so on greatest integer function of x plus n minus 1 by n. See, always greatest integer function of n times x. So n belongs to natural number. This is very important. The proof we'll discuss later. So you have to remember this pattern. You can see x plus 1 by n. If I take, for example, if you take the first term, take n. If you take second term, you can see n is equal to, so 1 if you put here, n is equal to 1 if you put, you will get greatest integer function of x. First term you will get. So n is equal to 2, you can put 2 minus 1, it is 1 by n, x plus 1 by n, the second term you will get, right? I hope everyone understand, right? Okay. This is the set of the series, right? It is always greatest integer function of n times x. N belongs to natural number, right? Okay. Next, you can see the next thing is, so suppose the greatest integer function, let's take k, right? The first observation you can see, if k is, suppose you can see, does not belongs to integer. You already know that greatest integer value is always integer, right? Suppose if it is not belongs to integer, is there any x value possible? X belongs to empty set. For example, greatest integer function is equal to k, suppose 2. If 2 is does not belongs to integer means what? It's not possible, right? 2 belongs to integer, right? There is no such x value such that, right, the greatest integer function is equal to that k, right? Because you know that greatest integer function is what? Is the integer's value. This is not possible, right? Okay, let me take second one. Suppose k is belongs to integer, right? So then the greatest integer values of x is equal to k, then where the x value is possible here? K is, so x should be k to k plus 1 is possible. K is included. Clear? For example, greatest integer function of x is equal to, let's take 10 you can take. So x you can take from 10 to, so you can see you can draw the number line. This is 10 here. So here 11 is there, here is 9 is there. You can take less than 10, what will happen? 9.5 you can take. Greatest integer function of 9.5 is 9. So 9 is equal to 10. It's not possible. Let's take 10. 10 is included, means 10 is equal. Greatest integer function of 10 is 10. So 10 to 11 you can take. Let's take 10.9999 you can take. So greatest integer will be 10 only. So you can take 10 to 11. If you take, greatest integer value of 11 is 11 only. That's not possible, right? So therefore you can take up to strictly less than 11. You should not include 11. That means the x will be k to k plus 1. K here is what? 10. 10 plus 1 is 11. I hope everyone understood, right? Okay, fine. Let's take one more example. Suppose the greatest integer function of 2x is equal to, let's take 5. So what is the x value? Where the x values you can take? So by definition is what? 2x is equal to what? 2x from 5 to, right side whatever it is there, from 5 to 5 plus 1, that is 6, right? By definition you can see x will be k to k plus 1, strictly less than, right? So we need x, you divide by 2, 5 by 2 less than x less than 6 by 2, clear? So that is 5 by 2 is what? 2.5. So 2.5 less than x less than 3. I hope everyone understood, right? In this interval only, that greatest integer function of 2x equal to 5. Clear? Okay, so let's take another example. Let's take greatest integer function of, let's take so minus x by, let's take 5 you can take. It's equal to, let's take 10. Okay. So then how to find the x value? So you know that minus x by 5 will be from 10 to, by definition you know, right? 10 to 11, right? So we need to find the x value. Who is disturbing here? 1 by 5 is disturbing and minus 1 is also disturbing. So you have to multiply by 5. What will get? 10 into 5 is what? 50 is less than minus x is strictly less than 55. Clear? So multiply 5 means 5 into 10 is 50. So minus x less than 55, right? So now we need to remove the negative one. How to remove this? You know that when you suppose if I take 3 is greater than 2, when you multiply negative 1, minus 3 should be less than minus 2. So when you multiply the negative number, so negative 1, the inequality will be changed, right? So the same way you can multiply by minus 1, what will get? Minus 50 is greater than or equal to x, strictly greater than minus 55, right? So you are multiplying, right? 50 to 55, right? Yes, correct. So when you rearrange it, smallest one you can write first, minus 55 less than x less than or equal to minus 50. Clear? I hope everyone understand, right? Okay. So fine. So we'll do the next question. Next you can see, we'll do the one by one. So greatest integer function of 3x you can do. So before that we have to understand the fractional part function also. Then only we can solve these questions, right? You can see Before that, I will add another page. I hope everyone understood the greatest integer function. The greatest integer function is functions from real number to integers. So we need to find the greatest integer less than or equal to that number, right? Okay. So we'll do more problems. First, we'll understand the fractional part function, and then what is the relation between greatest integer function and the fractional part functions, right? Okay. Let's understand the fractional part functions. Fractional part functions. Okay. What is that? Fractional part function is definition is what? X minus greatest integer function. This is the definition of the fractional part function. For example, if I take if x belongs to integer, then fractional part function's value is what? 0, right? For example, if I take a 2, so 2 minus greatest integer function of 2, that is 2 minus, you know that greatest integer function of 2 is what? 2, right? It will be 0. One observation, right? Let's take a greatest integer function of 1.5. So 1.5 minus the greatest integer function of 1.5. Clear? So what is the value? 1.5 minus greatest integer function of 1.5 is what? Greatest integer function of 1.5 is 1, right? You'll get 0.5. Clear? Okay. So then how to define the greatest integer function? You can see how to define the fractional part functions. The fractional part function you can see here, when you take 0 to 1, right? When you take 0 to 1, that means 0.1 to 0.999 you are taking, right? This value, you will get the same x value only. For example, if I take, you can see here, suppose if I take x is equal to 1 by 2. So what is the fractional part function? So fractional part function of 1 by 2 is equal to 1 by 2 minus greatest integer function of 1 by 2. 1 by 2 is 0.5. That is your x here. This is x. And greatest integer function of 0.5 is what? 0. Right? Therefore, you can, so you are taking, what is x here? 1 by 2. So you are getting the same value, right? So when you take 0 to 1, the fractional part function of that will be x, same x value. X here may be from 1 to 1, 0 to 1, right? When you take 1 to 1 to 2, you are taking the, what is the fractional part function? Let me take 1.5 you can take. So 1.5, you already discussed that. Fractional part of 1.5 is what? So 1.5 minus 1, that means 1.5 here is a what? X, any value from 1 to 2. So therefore, how to define x minus 1 you can write. Let's take a 2 to 3 you can take. So 2 to 3, let's take a 2 to 3. If I take 2.5 you can take fractional part of this one. So 2.5 minus the greatest integer function of 2.5 is what? So 2, that is x minus 2 you can write. Here x we are taking 2.5. Understood? Generalized x minus 2 you can write. The same way, if I take minus 1 to 0 you can take. In this interval, what is the fractional part function? X plus 1, right? You can check it here. Let's take minus 0.5 you can take. You can verify that you will get x plus 1, right? If I take minus 2 to minus 1, that will be x plus 2. This is your fractional part functions, right? So one observation you can see, if you put minimum value here, you can see the left side of the input value, 0 if you put 0. If I hear 1, if you put 1 minus 1, 0. If I put 2 here, 2 minus 2 is 0. So therefore, minimum value of the fractional part function is 0. What is the maximum value? Maximum value you can see, if I take 0 to 1, 1 you put 1. But you should not take 1 here. Let's take 2 here. 2 minus 1 is 1. The maximum should be strictly less than 1. You should not take 1. right? Because the maximum value here, the output, you know that the boundary is not included, right? Okay. Therefore, how to define the, how to draw the graph of the fractional part functions, you can see. Let me take the color 0, 1, 2, 3, 4. Here minus 1, minus 2, here is minus 3. Okay, so the output value here is 1 only is required. You know that 0 to 1, y, this is y, right? This is y is equal to x, y is equal to x. You know that how to draw the y is equal to x, right? This one, right? Correct? So y is equal to x passing through the origin, but you should not take 1, right? Because if you, here is strictly less than 1, you cannot include it, right? Okay, let's take 1 to 2. 1 to 2, you can take x minus 1. Just y is equal to x is there, no? You can shift 1 unit down, right? This is 1 unit down. X minus 3 like this. X minus 2, x minus 3. This is y is equal to x. X minus 1, this is y. X minus 2 is equal to y. X minus 3 is equal to y. Clear? The same way, you can take the left side, minus 1 to 0, x plus 1. Y is equal to x graph is there, no? You shift 1 units up, that is x plus 1. Okay? X plus 2. Like this, right? This is your fractional part of functions. This is your fractional part of x here. I hope everyone understood, right? Okay, so the first observation, you can see the properties. The fractional part function is, what is that? More than or equal to 0, strictly less than 1. This is a range. Range of the fractional part function is what? 0 to 1 only, right? Okay. Second thing, the fractional part of x plus or minus n, you can write as the fractional part of x, you can write, because n belongs to integer. So if n belongs to integer, the fractional part of x plus or minus n is equal to fractional part of x. For example, here fractional part of x plus 1, it is same as the fractional part of x. For example, if I take x equal to 1.5, the fractional part of 1.5 plus 1 is what? Take LHS. 1.5 plus 1 is the 2.5. 2.5 here. The right side is 1.5, right? So 2.5 fractional part function is what? 2.5 minus greatest integer function of 2.5. So 1.5 fractional part function is what? 1.5 minus greatest integer function of 1.5. Clear? So 2.5. So greatest integer function of 2.5 is what? 2, right? So 2.5 minus 2 is what? 0.5. 1.5 minus 1 is what? You know the greatest integer function of 1.5 is 1. So therefore 1.5 minus 1 is 0.5. It's satisfied. If it is n belongs to integers, greatest integer function of x plus or minus is equal to the fractional part of x, right? The fractional part of x plus or minus n is equal to fractional part of x only, you can write when n belongs to integers, right? Okay, this next thing is, what is that? Suppose, so fractional part functions, you can take suppose some k, right? Suppose if you take k is does not belongs to 0 to 1. Whatever the value you are taking, right? So the fractional part function is range is what? 0 to 1. Suppose if it is not lies in that interval, is there any x value possible? No, because the fractional part function is always 0 to 1, right? So there is no x value, x belongs to empty set. Suppose if k is 1, you can take, this is second one, this is third one you can take, right? So 0 to 1 you can take, then x is how to write it? So n plus k you can write, where n belongs to integer. Understood? For example, if I take a fractional part of, let's take, let's take 2x is equal to, let's take 1 by 2. Here 1 by 2 is what? 1 by 2 is belongs to 0 to 1 only, right? The output is, the fractional part function is lies in 0 to 1, right? So 0 to 1 is there. Then you can find the x value. What is the possibilities there? X is, so instead of x, here 2x is there. 2x will be n plus 1 by 2. Understood? Here n belongs to integer. So what is x here? You have to divide it by 2. What is that? You can see, if you need, you can, so n plus 1 by 2 you'll get, right? Therefore, x is equal to, you divide it separately, n by 2 plus 1 by 2 is what? 1 by 2 divided by 2, it is 1 by 4, right? Correct? I hope everyone understand, right? Okay, this is your x value. You can take n belongs to any integers. So there are infinitely many solutions is possible here. Okay. So let me take one more example. Let's take a fractional part of, let's take x by 2. So let's take here is 1.7 you can take. Is there any possibilities there? The output is more than 1 is there. So definitely you can say that there is x belongs to empty set. There is no such x value possible such that fractional part of x by 2 is equal to 1 by 1.7, because the reason is the 1.7 is just not belongs to 0 to 1, right? Let me start with a different example. Okay, let me start with this. Okay, first you can see greatest integer function we discussed. What is the relationship between the fractional part function and greatest integer function? You can see the greatest integer function, how to write this, always less than or equal to x. It should be more than x minus 1. The first thing. Next is the fractional part function. The fractional part function is definition is what? X minus greatest integer function. So then how to write x? X may be any real number, right? So fractional part function plus greatest integer functions you can write. Understood? Any real number we can write the sum of the fractional part functions plus the greatest integer functions you can write. Okay. Now let us do the one by one. So greatest integer function of 3x is equal to minus 9, right? By definition of the greatest integer function of x is equal to k means what? X should be k to k plus 1, right? The same way, instead of x which is there here, which is there, 3x is there. Therefore, 3x is lies from minus 9 to k here is minus 9. Minus 9 plus 1 is what? Minus 8 here. Understand? Okay, now you can divide it by 3, right? We need x, right? Minus 9 by 3 is less than or equal to x less than minus 8 by 3 is your answer. Clear? Okay. Let me take, this is your first one. Second one you can take. What is the second one? So, greatest integer function of minus x by 3 is equal to minus 6. You can take. By definition is what? Minus x by 3 is from minus 6 to k plus 1. What is k here? Minus 6 plus 1. Minus 6 plus 1 is minus 5. So we need to find x here. First you have to remove the 1 by 3, have to multiply 3 here. So minus 18 less than minus x, strictly less than minus 15, right? So I hope everyone understand, right? Okay. So 3 you can multiply minus 18, there you can multiply minus 15. So we need to find x values, right? So the minus 1 is disturbing. How to remove this? You have to multiply by negative 1. So 18 is greater than, when you multiply the negative 1, so inequality will be changed, right? X is greater than, so plus 15, right? Okay, therefore the x is 15 to 18 will possible, right? Okay, fine. So next question you can see, third one is what? Greatest integer function of minus x by 3 plus 1 by 2. Minus x by 3 plus 1 by 2 can take. So this equal to, what is that? 13 by 6. 13 by 6, it is 6 is not a factor of 13, it is decimal only will come. So it is not going to be integer. Therefore 13 by 6 does not belongs to integer. Therefore x belongs to empty set. There is no x value possible, because you know that greatest integer function is always integer, right? Okay, let me take another example. So log x base 2 is equal to 1. So log, this is third one, this is fourth one, right? This is third one, this is fourth one. So log x base 2, the greatest integer function is equal to 1, right? Check it once. Yes, log x base 2 is equal to 1. So you can use the definition. So inside log x base 2 will be 1 to k plus 1. K here is what? 1. 1 plus 1, it is 2, strictly less than 2. So we need x. How to remove the base 2, log base 2? How to remove that? The inverse process, right? What is the inverse of log base 2? 2 you have to raise, right? Base you have to raise by 2, right? 2 power 1 is less than 2 power log x base 2 is less than 2 square. Then 2 less than, you know that 2 log base 2 is, 2 power log base 2 is what? 1. So x less than 4, right? This is your answer. Okay. Let's do the fifth one. Fifth one you can see. What is the fifth one? So greatest integer function of x by 2 plus 5 by 3 is equal to 2. Greatest integer function of x by 2 plus 5 by 3 is equal to 2. 5 by 3 is equal to 2. You can see. Okay. Okay, fine. So how to find out the student quickly? The same idea. Instead of x here, x by 2 plus 5 by 3 is there, right? You check it once, it's correct or not. 5 by 3, yes, correct. So from 2 to 2 plus 1, it is 3, right? So we need to remove 1 by 1. Plus 5 by 3, you have to remove it. 2 minus 5 by 3, you can add it, add minus 5 by 3. So x by 2 plus 5 by 3 minus 5 by 3 will be cancelled. So 3 minus 5 by 3 will get. So 3 into 2 is 6 minus 5, it is 1 by 3 less than x by 2 less than 3 into 3 is 9. 9 minus 5, that is 4 by 3, right? So we need to find x. So the disturbing is what here? 2. How to remove the 2 base, that is fraction is 1 by 2 is there, right? So how to remove this? You have to multiply by 2. 2 by 3 is less than x less than 2 into 4 is what? 8 by 3 is your answer, right? Okay, let's do the more questions in the fractional part functions, right? So fractional part of x is equal to 0.1. You can see the sixth question. You can see, so you can see seventh question, you can see, I think one question is erased actually. So the same model only you can do it, right? And you can see seventh question, you can see the fractional part functions of x is equal to 0.1, right? So seventh question, you can see fractional part of 0.1. What is that? Fractional part of x equal to 0.1. Sorry. Fractional part of x is equal to 0.1. So you know that 0.1 is belongs to 0 to 1, right? So x, sorry, what is that? 0.1 is there, no? It is belongs to 0 to 1. Therefore, it is possible. So x is equal to, so you can write x is equal to n plus 0.1. So n is, because any real number, you can write sum of greatest integer is n here. N is integer plus the fractional part functions, right? Okay, so x is equal to n plus 0.1 you can take. So n is belongs to any integers. So there are infinitely many solutions is possible. Depends on the n, you can find the different x values, right? Okay. So fine. Next you can see next question. I think you can do it easily. So you know, I will do this one model. Fractional part of 2x minus 1 is equal to 1 by 2 you can take, right? Fractional part of, what is the next question? Fractional part of 2x minus 1. 2x minus 1 is equal to, what is there? 1 by 2. Okay, how to do these questions? You can see by definition of fractional part of x minus n is equal to fractional part of x if n belongs to integer, right? You already know that. We discussed it. Okay, therefore, fractional part of 2x minus 1 is equal to fractional part of 2x because 1 is belongs to integer, right? So, this is equal to 1 by 2. So, 1 by 2 is belongs to 0 to 1. So, in this interval is there lies. Therefore, you can find the solutions, right? Therefore, 2x is equal to n plus 1 by 2. So, x is equal to n by 2 plus, so 1 by 4 you can write, right? Divide by 2, right? So, divide by 2, n by 2. So, 1 by 2 by 2 is 1 by 4, n belongs to integer, right? Okay. So, I hope everyone understanding, right? So, the same way you can do the rest of the question. You can see the 13th one, you can see the fractional part of 3x equal to square root of 2. Square root 2 is what? 1.414. It's more than 1. This is x belongs to empty set because fractional part range is what? 0 to 1. If there is this x values, whatever the output is not belongs to 0 to 1 means there is no such x value possible, right? X belongs to empty set. I hope all of you understand. So now we'll go for the next problems, right? So because remaining things easy only, you can do it, right? Okay, so let me take the first question here. Okay, so 2 times the greatest integer functions of x plus x is equal to 6 times fractional part functions. I'll teach you very interesting method, right? Easily you can solve by algebraic and graphically also. So first I will teach you the you know, that algebraic way. First let us take, let greatest integer function, let's take n, and the fractional part function, let's take m, right? But you know that fractional part function definition is what? X minus greatest integer function. Clear? Okay, then how to write x? Fractional part function plus greatest integer function you can write. That means any real number you can write the sum of the fractional part function and greatest integer functions you can write. That means x how to write? M plus n form you can write, because I am considering fractional part is m and greatest integer function is n. Okay, now you can substitute it here. What will get? So you can see here 2 times, I'll start from here, right? So 2 times greatest integer function plus x is equal to 6 times fractional part functions, right? 2 into greatest integer function we consider is n plus x, how to write? M plus n is equal to 6 times fractional part function is m. So you can simplify this. You can see 2n plus n is what? 3n plus m. So minus 6m is equal to 0. Clear? So now 3n. So m minus 6m is what? Minus 5m is equal to 0. So we need a fractional part range. The fractional part is 0 to 1 only lies, right? So therefore you have to write m in terms of n. So then how to rewrite this one? 3n is equal to 5m you can write. So you can see 3n by 5 is equal to m you can write. But you know that what is m? M is equal to the fractional part functions. You know what is the range of this? 0 to 1. But what is m here? 3n by 5. 3n by 5 is less than 1. Understand? Okay, now we need to find the n. What are the integers value possible? Multiply by 5 both side. 0 less than 3, n is less than 5. Now you can divide by 3. 0 less than n less than, divided by 3 means what? So 5 by 3 you'll get. 5 by 3 is what? So 1 point something. 1 point something is there, right? So 1 point something, right? 1 times 3 is 3. So 2 is there. So 26, 1.6 will come, right? Yes, 1.6. So what are the integers from 0 to 1.6? You can take n is equal to 0 and 1 only possible. These are the only integers from 0 to 1.6, right? Okay, now we need to find the x value. Very simple. What you can do? X is equal to m plus n, you know, right? First you have to write everything in terms of n. What is m here? 3n by 5, right? 3n by 5 plus n, correct? So x is equal to, you can take n out, 3 by 5 plus 1, right? You can take 3 by 5 plus 1. So x is equal to n. If you take, what is the 3 plus 5? You take the LCM, right? 3 plus 8 by 5, right? Check it correctly or not. 5 you take LCM. So 3 plus 5, it is 8 by 5. So x is equal to 8 by 5 n. So what are the n value possible? Suppose if you take n is equal to 0, x is equal to 0. Suppose if n is equal to 1, x is equal to 8 by 5. These are the two real solution is possible. They're asking that sum of the solutions of the equations. So what they will ask here, sum of the real solution means what? 0 plus 8 by 5. The sum of the solution is what? 0 plus 8 by 5. This will be 8 by 5 is your answer. Understood? Okay, we'll go for the next question. You can see the equation has a k real roots. Find the values of k. Let me take the same idea. The let fractional part functions you can take m, greatest integer function you can take n. So then how to rewrite this? 4 times fractional part functions x plus greatest integer function. 4 times m is equal to, how to write x? You know that x is equal to greatest integer function plus fractional part functions, right? So x is equal to m plus n, right? Okay, so you can rewrite this. You can see fractional part function plus the greatest integer functions, x is equal to m plus n you can write. Okay, just you replace m plus n here. Greatest integer function of x is n, right? Now you can simplify this. 4m is equal to m plus 2n So 4m minus m, right? So equal to 2n. So 3m is equal to 2n, right? I hope everyone understand, right? So we need m into n, 2n by 3 you'll get, right? But you know that m is range is what? 0 to 1. What is m? 2n by 3 you can substitute. You can find the n range, n values, right? You multiply by 3 first, 0 less than 2n less than 3. Now you can see you have to divide by 2, right? Because we need n only. 0 less than n less than 3 by 2. 3 by 2 is what? 1.5. So what are the integers value? What is n here is what? Greatest integer. What are the values possible? 0, 1 only possible. Understood? Now you can find the x value here. What is x? M plus n. X is equal to, what is m here? 2n by 3 plus n, right? So x is equal to, you can take n out, 2 by 3 plus 1. So x is equal to n, you take 2 plus 3 by 3. Correct? I am taking LCM 2 plus 3 by 3, correct? It is equal to n into 5 by 3, right? So therefore, x is equal to 5 by 3 n. Suppose if n is equal to 0, what is x value? 0. If n is equal to 1, x is equal to 5 by 3. So here also 2 solutions. Therefore, the k real root is possible. The value of k here is 2. The number of roots is 2. So k here is what? 2. I hope everyone understand. Okay, let's go for the next question. So how to solve this question quickly? You know that the greatest integer functions, let's take n. Fractional part functions, you can take m. So how to rewrite this equations? You can see greatest integer function into fractional part function plus x is equal to 2 times fractional part function plus 10, you can see. Then how to rewrite this one? Just replace greatest integer functions equal to n, fractional part functions m, plus, you know that how to write x? M plus n, you write m is the fractional part function, n is the greatest integer functions, right? So m plus n you can write. So 2 times the fractional part functions here is m, right, plus 10. You can simplify this. You can see this is mn plus m plus n minus 2m minus 10 equal to 0, right? You can see, so m here is minus 2m is there, right? So what is that? mn minus m plus n minus 10 equal to 0. Clear? So m minus 2m, clear? M minus 2m is minus m only. You can see here, student. So how to write this one? M you can take it out, n minus 1, right? It's equal to 10 minus n, we can write. Clear? So minus 10 you send to the right side, plus 10, plus n you send to the right side is minus n, right? So first 2 terms I am taking m out. So n plus 1, right? So sorry, first, okay, here this term and this term you can see. Which term you are taking? So which term we are comparing here? mn I am keeping as it is. M minus 2m is minus m, n minus 10. Yes, correct. So this first 2 terms you can see m, you take it out, n minus 1 is equal to 10 minus n. So m is equal to 10 minus n divided by n minus 1, right? Clear? Fine. Okay. So now you can see the range. What is that? M range is what? 0 to 1. So you can find out it. What is M here? 10 minus n divided by n minus 1 is less than 1. Now you have to solve this one, right? How to find the n value here? Okay, you can see, student, so here n is any numbers, no, so you cannot solve like this. You can see this is, you can split it, right? You can split this one, then what will get? So 10 minus n divided by n minus 1 is greater than 0, and 10 minus n divided by n minus 1, this should be less than 1. Solve this one, you can find the n here. So you can see how to solve this one. You can see if I take minus out, what will get? N minus 10 divided by n minus 1 is greater than 0. Clear? So we need to remove the negative 1. So you have to multiply by negative 1. What will get? N minus 10 divided by n minus 1 is less than or equal to 0. Clear? You have to multiply by negative 1, right? So inequality will be changed, right? Okay. Fine. So now you can see here. So you can see 10 minus n divided by n minus 1. Minus 1 you send to the left side, less than 0. You take the LCM, 10 minus n minus n. You can take the LCM, minus n plus 1 divided by n minus 1 is less than 0. Strictly less than 0, right? Check once, 10 minus n plus 1. Yes, correct. So then it is equal, how to write 10. So 10 plus 1 is 11. So minus 2n, right? Is it correct? Minus n minus, that is plus 1 is correct. 11 minus 2n, right? Divided by n minus 1 is less than 0. Clear? Okay. So 11 minus 2n, yes, correct. Now you can take these two ones. Let's take this is 1, this is 2. Okay, you can compare these 1 and 2 right here. You can take the and is there. Now you have to take the intersection. Then you can find the n values, right? Okay. So first one you can see n minus 10 divided by n minus 1. N minus 10 by, so what is that? N minus 1, right? N minus 1 is less than 0. And second one you can see, student, what is that? 11 minus 2n divided by n minus 1. 11 minus 2n. 11 minus 2n divided by n minus 1. Here is less than 0, right? Less than 0. Here also less than or equal to 0, right? Less than or equal to 0 here. Here strictly less than 0. You have to be very careful here. 11 minus 2n by n minus 1 strictly less than 0. Here less than or equal to 0. Okay, let me start with here. You can see we already discussed that, wavy curve method. So if you're not able to understand the wavy curve method, you can watch my Math J Academy wavy curve method one shot video is there. 1.5 hours video is there. You can watch it. You can able to understand. Okay, you can see here the critical point here you can equate to 0. N minus 10 equal to 0. N is equal to 10. So n minus 1 equal to 0. 1 and 10 is the critical point. Now we need actually the ratio should be less than or equal to 0. You can start with a positive. Then you can see the 10 is odd power, change the sign. The 1 is odd power, change the sign, plus minus plus. So we need, what is we need actually? So ratio is less than 0. Therefore, n belongs to, so 1 is included or not? 1 is not included because if you put 1 here, so denominator is 0. 1 to 10. 10 is included. No issues, right? Okay, let's start here. Let's take minus, if you take common, 2n minus 11 divided by n minus 1 is less than 0. So these kind of question, what you can do, you have to see the factors should be n minus something, not constant minus something, right? Okay, So for that I am taking minus out. So you multiply by minus 1. Multiply by minus 1, what will get? So 2n minus 11, correct? N minus 1 is greater than 0. Now you can see what are the critical point here? 11 by 2 and n. 2n minus 11 equal to 0. So 11 by 2. So 11 by 2 here, and then here is 1. You can start with a positive. Start with a positive. So 11 by 2 is odd powers, change the sign, the minus. So 1 is also odd power, change the sign is positive. So we need x is belongs to minus infinity to 1. 1 is not included. If you put 1 here, denominator 0, we need greater than 0 is required. Union 11 by 2 to infinity. 11 by 2 also is not included, because if you included, it becomes 0. So let's take, this is 1 here, this is 2, right? So we consider here this is 1 and 2, right? So need to take the intersection of these two. We can find the n values, right? So let me take another page. So this page. So what are the things here? You can see. So what is the x value? So 2 is there. Okay. Here, yes, page number 11, right? So 1 to 10 and minus infinity to 1. 1 to 10 you have to take first. Otherwise, we do one thing. You can size, you can reduce, right? You can find out here only. Okay. So you can draw the number line. What is that? First 1 to 10. So 1 here and 10. Okay, so fine. So 1 to 10 means 1 is not included and 10 is included. Okay, first one. Next is minus infinity to 1. Minus infinity to 1. So that means I will take another color. Minus infinity to 1. 1 is not included. Then 11 by 2 to infinity. 11 by 2 is what? So if 5 point something, right? 5.5, right? Here it will be there. 11 by 2 you can take. Okay. 11 by 2 to infinity. You can see this is, you can see the white color and green color regions. You can see which is your common regions. You can see, student. So more than 10, there is no common, and you can see z 1 to 11 by 2, the green color is not there, and less than 1, white color is not there, which is common here. You can see the both will be there in this regions only. So therefore, so n is 11 by 2 is included, right? 11 by 2 to 10 is included or not? 10 included. Okay. This is your common regions. So 11 by 2 is what? 5.5, right? So yes, 5.5 to 10. So what are the integers? You can see when you take the integers value, here is 5, 6, 7, 8, 9, 10. So 5.5. So here 5.5. This is 5.5, right? 11 by 2. It's more than that we need actually. So 5 you cannot take it, right? So more than 5.5 and less than or equal to 10. What are the integers values possible? So you can see the integers value will be, so 5 is possible or not? So it is not possible, right? Because it's more than, so we need this interval, right? So therefore 6, 7, 8, 9, 10 only possible, right? Okay, so we got the n values are 6, 7, 8, 9, 10. These are the natural These are the integers value. Let me start with the equations here. So we need x values, right? I will solve here. So x is what? M plus n, right? What is m here? You can see we got m here is 10 minus n divided by n minus 1 plus n. So x is equal to, you can write in terms of n, right? 10 minus n. So you can take here is take LCM, n square minus n divided by n minus 1. So 10 minus n square minus n. Yes, correct. So therefore x is equal to n square minus 2n plus 10, right? Divided by n minus 1. This is your x value. Suppose if I take x is equal to 6, what are the, sorry, n is equal to 6. 6, 7, 8, 9, 10 is possible, right? You can see what are the n values possible? 6, 7, 8, 9, 10. Suppose you can see here. So what is that? Suppose n is equal to, where is that? Here, one thing, one minute. You can see n is equal to 6, you can take n is equal to 7, n is equal to 8, n is equal to 9, n is equal to 10, you can see. You can find the number of solutions, right? So you can see if you put n here, you will get one solution. Just you can find out here. Because I took more than 1 hour class, just you can solve it. If you put n is equal to 1, sorry, n is equal to 6, you can find one solution because it defined. And n is equal to 7 you can take, n is equal to 8 you can take, n is equal to 9, n is equal to 10. There are 5 different solutions is possible. 5 real solution is possible here. Understand? Understand? So the number of solutions of the equation is 5 because the x is depends on the n. How many n's will be there, that many x will be possible. Because you can see it is all values of n, it is defined denominators. Therefore, so different n value, different x value is possible. Therefore, the number of real solution is what? 5 real solution is possible. I hope everyone understand, right? You can do it. Find the exact value of the real number. Okay, we can do the one more questions quickly. So you can see the, find the sum of all the roots of this equation, right? Let's take greatest integer functions, you can take n, and fractional part functions you can take m, and you can see x is equal to m plus n, right? You already know that. So 2 times n is equal to m plus n plus 2 times the fractional part functions, how to write? So m, right? Okay. Therefore 2n m plus m. So 2m plus m is what? 3m plus n, right? So then how to write? 2n minus n is equal to 3m, right? Okay, so therefore you can see that n is equal to 3m. Clear? So therefore we got it, n is equal to, just you can observe that 2n minus m, you can send this, m plus 2m is 3m, yes, correct, n is equal to 3m. Okay, so then x is equal to, you know that m plus n, so you can find out x here. X is what? M is what? You have to write m in terms of n, right? M is equal to n by 3, right? You can substitute it here, n by 3 plus n. I think if you take n out, what will get? 1 by 3 plus 1, that is 2 by 3 into n, right? 1 plus 3, no? What is that? 1 plus 3, it is 4 by 3 n, right? So we got x value, then you can do it easily, right? So what is the range of n? So m is 0 to 1, you know, right? So 0 less than n by 3 less than 1, you multiply 3 both sides. What will get? 0 less than n less than 3. So Correct? You multiply 3. What is the n value possible? 0, 1, 2 only is possible, right? So you can see what is the x, we got it. X here is 4 by 3, n. If you put n is equal to 0, x is equal to 0. N is equal to 1, x is equal to 4 by 3. If n is equal to 2, x is equal to 4 by 3 into 2, that is 8 by 3 is your solutions. I hope everyone understand. So if you like this video, please subscribe my channel, and you can share to your friends. They can benefit, you know, so 100% for the IOQM. If you need more videos, you can wait for the coming weeks. I will post more videos coming days with the different geometrical ideas, because due to the more classes I cannot able to constantly post the video. So I try to post continuously coming days. So please subscribe my channel. Thank you everyone. Thank you.